You know, for years, AI in medicine has kind of felt like something straight out of a sci-fi movie, right? But that's all changing, and it's changing fast. Right now, AI is going from just an idea into one of the most powerful tools we've ever had, and it is sparking a full-blown revolution in our health. So, let's get into it.
I mean, that's a huge question. But here's the thing. It's not just a what if anymore. The potential is so massive that we have to ask ourselves, are we standing on the edge of a brand new era in medicine? One where AI can actually help us solve the unsolvable?
So here's how we're going to break this down. Think of it like we're using an expanding lens. We're going to start super small, at the microscopic level, with proteins. Then we'll zoom out to the labs searching for cures, then into your doctor's office, then out to you, the patient. And finally, we'll look at the big picture, how AI could remake the entire system.
It's simple, right? To fix something, you first have to understand how it works. And when it comes to medicine, that means we have to start at the molecular level, with the tiny, tiny things that literally make our bodies run.
Pretty much everything that happens in our bodies, it all comes down to proteins. You can think of them as these tiny biological machines. And just like any machine, the secret to what it does is its shape, its 3D structure. The problem is, for decades, figuring out that shape has been one of the most incredibly complex, mind-numbingly slow processes in all of science.
And this really shows you the leap we've just taken. It used to take a scientist their entire PhD, years of their life, to map just one single protein. Then Google's AlphaFold AI comes along and predicts the structure of over 200 million of them. That's pretty much every protein we know of. This isn't just an improvement, you guys. This is a whole new reality for science.
And that number, 2.5 million, that's where you see the real-world impact. This isn't just a bunch of data sitting on a server somewhere. No, it's a completely free toolbox that scientists in over 190 countries are using right now to speed up the fight against malaria, to better understand tuberculosis, and to finally make progress on diseases that have been neglected for way too long.
Okay, so we understand the building blocks. But so what? How does that help us find a cure? Well, once you can see the actual machinery of a disease, the very next step is to figure out how to fix that machine. And this is where AI is absolutely supercharging the hunt for new medicines.
So meet TxGemma. You can think of it as a special kind of translator. It's an open-source model that understands two totally different languages, the language of medical research papers and the chemical language of molecules themselves. And by bridging that gap, it can help scientists spot promising new drug candidates way, way faster.
Here's how it actually works. A researcher can basically have a conversation with the AI. They can say, hey, find me a gene that's linked to this disease. Then, okay, great, now find me a compound that might target that gene. And it can even predict how well it might work, all while the researcher can ask questions and really understand its reasoning. It completely streamlines a traditionally slow and expensive process.
And this is where it gets absolutely incredible. In one test, the model made a connection that, well, it wasn't supposed to be able to make. It found a gene for ovarian cancer and a drug that could block it, even though that specific link wasn't anywhere in its training data. And the crazy part? According to current medical research, it was right. This is a glimpse of AI making brand new scientific discoveries, all on its own.
All right, so we've been in the research lab. Let's zoom out a bit and walk into the clinic. Because one of the biggest crises in healthcare today isn't a lack of knowledge, it's a lack of time. Doctors are just buried under this mountain of administrative work.
I mean, this chart says it all, doesn't it? So much of a doctor's day is just paperwork. Drafting notes, filling out forms, answering messages, and every minute spent doing that is a minute they're not spending with their patients, listening, connecting, and showing empathy.
This is where the idea of an AI copilot comes in. Just imagine tools like ambient scribes that listen in the background of your appointment and just write the notes automatically. Or models like MetaLem that can instantly summarize a patient's entire history to find the most important details. From that to specialized AIs that help radiologists sort through the 2 billion chest x-rays done every year. The goal is always the same: give doctors the gift of time.
Let's zoom out again, because this whole revolution isn't just for scientists and labs or doctors and clinics. It's about empowering every single one of us to take more control of our own health right from the palm of our hand, right?
Just look at these numbers. About half of adults in the US are using health apps, and a third of us have some kind of wearable device. We are all walking, talking generators of health data. Our heart rate, our sleep, our activity.
And AI is the engine that can turn all that raw data into insights that are actually meaningful and personalized for you.
And what's so cool is how this impact scales up. So, for you, personally, a health model might analyze your watch data and give you tailored wellness advice. But then you zoom out to the community level, and you see AI powering 3 million free tuberculosis screenings in India. And then you zoom out even more to a national level, where tools like the Open Health Stack are helping build apps to support maternal health across Kenya. It's amazing.
All right, for our final stop, we are pulling the lens all the way back. Because here's the thing. To make any of this actually work in the real world, you need a lot more than just a brilliant algorithm. You have to be ready to transform the entire ecosystem.
There's this idea from the Boston Consulting Group called the 10-20-70 rule, and it's absolutely crucial to get this. For a successful AI project, only about 10% is the actual algorithm. 20% is the tech and the data, but the other 70%, the vast majority, it's about people. It's about training, it's about changing how we work.
So, how do you get that massive 70% right? Well, it all boils down to one simple, powerful word: trust. And you build that by putting people at the center of everything, by rigorously testing for quality and safety, by proactively making sure these tools are fair and equitable, and by being open about what you're learning along the way.
This quote it nails it. Health moves at the speed of trust. You can have the most advanced piece of technology on the planet, but if doctors and patients don't have total confidence in it, it will never be adopted. You see, the technology is the easy part. Building trust, that's the hard part.
Look, the potential for AI to change health for the better is undeniable, and it's genuinely thrilling. But as we race ahead, the biggest challenge we face isn't about what the technology can do. It's about how we, as a society, choose to build it and roll it out. It's about how we make absolutely sure that this incredible new power to heal becomes a reality for everyone, everywhere.